Hello everybody. So what we're going to be looking at today is combining power series. Also, you can probably hear a lot of extra strange noises. It looks like they're, I don't know, doing construction in the apartment above mine. So I've been waiting for like 4 hours for them to stop and they haven't, so it is what it is. So there'll probably be power tools and all sorts of other stuff making noise right now. But it is what it is. We can't do anything about it. So let's go ahead and get started. So what we're looking at today is combining power series. So the idea behind this is that you learned a little bit about finding an interval of convergence for a power series, right? So that's in the last lecture. Power series. And interval of convergence. What we're going to do in this lecture, which should be a nice short one, is we're going to learn how to put different power series together and what happens. Okay, so it's not really that complicated of an idea. It's just like if you've got a power series and another power series, can you add them together? Yes, you can, and that kind of thing. So yeah, so let's go ahead and get started. So what we're going to be looking at in this section is, again, how to combine power series. So we're going to be looking at two power series where we already know that they converge. So you say like let, I don't know, Cn x minus a to the n from 0 to infinity. And I need another one, so let's call it n goes from 0 to infinity of dn x minus a to the n, be two convergent power series. And two convergent power series, and I want them to have the interval, they have a common interval of convergence. And that's something we're going to have to talk about with common interval of convergence. I. That's just an interval. Then what you could do is you could actually take these two series together, just put them together like this, Cn x minus a to the n plus dn x minus a to the n, kind of put that all in big parentheses here. That is a convergent power series. Is a convergent power series. With interval of convergence I. Also, if you want to add a minus on here instead of a plus, that's also fine. You can add them or subtract them. Everything is good. And of course, you can write that in a slightly different way if you wanted. You could realize that they both had an x minus a to the n there, so you could take it as Cn plus dn, or minus x minus a to the n. That's just using basic algebra to factor out the x minus a to the n. So, you know, there's various things that you can do there. And so the first thing you're going to have to deal with is what is that common interval of convergence about, right? What's this? Common interval of convergence I. And so what the common interval of convergence I is, it's just an interval. It's like the biggest interval of convergence that is inside the other two intervals of convergence, right? So the idea is, so the common interval of convergence is, mathematically, it's called the intersection of the intervals of convergence of the two original power series. for the two, that was supposed to be a W. So for the two original series. Words hard. Words hard. All right. Now, I mean, it's just easiest to see with an example. So let me come up with one. It is a little bit tricky to come up with a decent one, so I'll have to try here. Yeah, okay. So this will be pretty straightforward, I think. If an x to the n converges on negative 1/4 to positive 1/4, and the series bn x to the n converges on negative 1/pi, then what is the interval of convergence for when we add them together? So the series of an x to the n plus bn x to the n. What is that? And so really all you've got to do is figure out what the common interval of convergence is. So just look at a number line. It's not hard, it just seems hard before you've done it. So you've got a number line, right? And negative 1/4 to 1/4 is somewhere, right? Let's just say negative 1/4. Oh, come on. It's there, right? And so you have one interval, this one, that's from here to here. But then you've got another interval, 1/pi to negative 1/pi. If you grab a calculator, which I don't have, why would I? I mean, I'm only teaching a math class. If you grab a calculator, 1/pi, where's pi? Right there, right? That's 0.31, whereas 1/4 is obviously 0.25. So 1/pi was 0.31, right? Point is that's bigger than a quarter, right? So if you were going to draw it on here, then 1/pi is there, and then negative 1/pi is on this side. And so you have the other interval is from here to here. And so what you're asking yourself is what is common to both, right? So what is inside both? So what you're supposed to see is that you've got here and then you've got here. So the region common to both intervals, to both negative 1/4 to positive 1/4 and negative 1/pi to positive 1/pi is, well, it's just negative 1/4 to positive 1/4, isn't it? Right? Because this region right here is actually inside both of the other intervals. So that's all you need, right? So you just have to realize that. Negative 1/4 to 1/4 is in both. Okay, and that's all you're doing when you're doing a common interval. It's just where they overlap, where the two intervals overlap. So it's not meant to be some, super tricky thing. Okay, so pretty straightforward. Let's see if I can do another one. Blah, 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 blah. Yeah, let's do one more of those, I guess. Because they're giving you complicated looking series now. So -1 to the n plus 1, we're starting at 1, of 2x to the n over n has interval -1/2 up to +1/2 square brackets. I've got another one, 7x to the n, also from 1 to infinity. We're not dealing with when you don't have those match in this section. Kind of more of a pain to combine them in that case. -1/7 to +1/7. What do they want? Find the interval for, and I should be saying interval of convergence, and I'm just not, because I'm lazy. So I'm taking that first series right there. That's the top one, right? Top one. And we're gonna just take it and add it to the second one. So add it to this one. All right, so what is the interval of convergence for that? And again, you're just looking for where the two intervals overlap, right? So the common interval right? You've got -1/7 to +1/7. That interval. And then you've also got -1/2 to +1/2. That's a bigger number, right? So you got that'd be over here to here. Don't want to use that color. I want to use that color. So what is inside both of them? Just the part that's in between -1/7 and +1/7, right? That's the part that's in both. It's just this little section, right? -1/7, +1/7 is in both. That's your answer. Right? So don't get too confused on these, right? They make it sound like you're doing something complicated and you're not. What you're definitely not doing is trying to apply like the ratio test or something on here. They're already telling you you know a lot about the original series. You don't do a ratio test. Okay? All right. Now, there's only one other thing on here. So, let's see. Replacing the x with something else. Okay, replace x with bx to the m. What happens? Comma. Should probably be like a semicolon or something. I don't know. If I knew punctuation, I wouldn't be a mathematician. All right. So here's the idea. So theorem. All right. So suppose we're only going to be looking at a single series now. So suppose we have a series. Suppose I have a series, Cn x to the n. We're not going to move we're not going to put x minus a in there. We could, but we're not. So suppose this series, converges to f of x, right? Now, first of all, what do they mean by that? Well, what they mean by that is that this has an x in it, right? And this has an x in it. So since it's a power series, when it converges, right, it might converge to a number, but that number will depend on x. And so technically it converges to a function of x. So you'll even see them write like this, right? you'll even see like f of x equals, n goes from 0 to infinity of cn x to the n. Okay, they can do that because obviously there's an x over here on the right hand side, right? So that is a function of x. It's just an infinite polynomial for x. So it is a function of x, okay? So they say that, don't let that bother you here. So suppose that function, or sorry, suppose that series converges to f of x, all right? Then what you're gonna do is we wanna take this x. You know what I'm gonna do though? I'm gonna put that f of x on the other side, sorry. Like that, and then I'm also gonna just slide it over where it was. Okay, so suppose you have that. So you have a function cn x to the n equals f of x, okay, on interval I. To say that for x in interval I. Did I leave enough room for that? For in interval I. Okay. Then what we're going to do is we're going to replace the x with something more complicated. Now replace x with bx to the m. So that's not an n, that's an m, and it's just going to be a number, okay? That's just going to be a number. So the idea is you've got this x here, you've got this x here, you've got this x here, but what we're doing is we are replacing the x with all of this in for the x. So if you replace that, then you get cn, and it won't be x, it'll be bx to the m to the n. And what is that going to converge to, though? That's the question, right? What is that going to converge to? Or even does it converge? Well, guess what? It will converge. It will converge. What it will converge to is f of bx to the m, bx to the m, bx to the m, and it will be for, not for x in the interval I, it'll be for bx to the m in interval I. And so this part right here, the bx to the m in the interval I, is going to be a lot of the place where you have to do kind of a calculation there, right? So a lot of times what they're going to want you to do is figure out what the new interval is, right? So this right here is going to be, you'll figure out the new interval, and that'll be the problem that they want. The new interval of convergence. And that's actually the only other thing in this section that we haven't covered yet. It's just that. So let's try one. Let's see how it goes. So that's a theorem, okay? This is just how it works. I'm not going to prove it, but I mean, it's pretty simple, right? Like, if this is going to converge when you put a 3 in there, right? Then this series converges when, no, not Siri, go away, Siri. Then this series converges when you put in a 3, right? But up on the top one, x would be 3, and on the bottom one, bx to the m would be 3. So, right, they're still going to converge. Like if the first one converges, the second one's going to converge. It's just that you're going to have to plug in different x values to get the same result. Like if you want a 3, if you want that all to come up to 3, you're going to have to plug in a different x to get a 3 out of that than you do to plug in an x and get a 3 out of that. That's the idea. So it's really, I mean, there's really nothing there in terms of like complicated math. All right, let's do an example. So the interval of convergence of power series in 18x to the n minus 1 is negative 18 to positive 1 over 18. All right, that's normal. That's just like the normal kind of series you'd expect for like what looks like mostly a geometric series. Okay, sure, why not? They want to find the interval of convergence for, let's see, where is it? N 2/3 x cubed to the n minus 1. I put a +1 up here. This was supposed to be a -1. I don't know why I put it wrong. All right, so that's your problem. Okay, and what you're supposed to notice is that they took this 18x and they replaced it with this, right? Now, honestly, the hard part there is figuring out like what they had to replace the x with to get this, okay? And I'm trying to think of the easiest way to do it. Yeah, so I don't really know. So what I'm going to do is, I don't know what the easiest way is. So we'll just do it kind of a complicated way here. Let's see. So in the original, there was an 18x. Right? In the new one, in the new series, there is a 2/3 x to the 3, right? So you can at least see that. But the question is, what do you replace x by to get that? And that's not so easy. What did we replace x with to make that happen? All right, so what I'm going to do is this. I'm going to take the 2/3 x to the 3, and I want to see an 18 in here. I want to see an 18. Why an 18? Because the original had an 18, right? So what I'm going to do is I'm just going to multiply this by 18 over 18. Oops, I wanted to use red there. So I wanted to see an 18 there, okay? Now, if I see an 18 there, then this is actually, I can take the 18 on the outside, and then the 18 that's in the denominator, I can just put with the other stuff. 2/3 x cubed over 18. All right, so you see how I'm trying to make this look like the 18x? Right, we're trying to make this look like the 18x. So far so good. I just want to simplify the stuff that's in that set of parentheses a little bit. So I've got the 18 on the outside, and then on the inside here, I've got 2x cubed hold on a second here. Okay. Oh no, never mind. I was confusing myself temporarily. So this is 2x cubed over 3 times 18, which is 3 times 18 is 54, I believe, like that. But that is 18. The 2 over 54 is actually cancels. It's x cubed over 27, like that. And is that 18x? I think that's 18x. Okay, so I was trying to make it look like 18x, and I pretty much did. So this is like, let me write it here in a different color. So this is like 18x, right? But x is replaced with, what was it replaced with? X cubed over 27, right? So that's what you're going to do. So the old series was this. The old series, or the original one, converged when x is in -1/18 to +1/18, right? So that's this, x in between -1/18, +1/18. Now we're going to replace that x with x cubed over 27. We're just going to take this and replace it with this. So we're going to get -1/18 less than x cubed over 27 less than +1/18. And then what you have to do here is solve this for x. So what I'm going to do is I'm going to multiply every side by 27. So you're going to get 27 -1/18. Should actually switch colors. That's not switching colors. So you're going to get 27 times -1/18 less than just x cubed less than 1/18 times 27. So you get x cubed in between. 27/18 is actually 3/2, -3/2. And then we're trying to solve for x, so you should square root both sides, or cube root both sides. So you cube root everything, and you're going to get -3/2 to the 1/3 less than x less than 3/2 to the 1/3. Which is negative, you can write it as a root if you want, you don't have to. Negative cube root of 3/2 to positive cube root of 3/2. And that's your interval. So negative cube root of 3/2 to positive cube root of 3/2. And you should be able to type that in as a power, and it should accept it. You shouldn't have to use a root. All right, so that was a complicated one, but let's do an easier one real quick and see if maybe it seems easier now. So again, you have to figure out what you replaced with the x with. That's kind of the hard part. Once you do that, you just replace it in the inequality for the interval of convergence and have to solve for x. So here's one. The interval of convergence of Cn x to the n-1 is -1/5 to +1/5. Hey, they didn't give us a real series. They just called them C's. That's fine. So interval of convergence there is -1/5 to +1/5. Find the interval for series Cn 4x to the n-1, 1 to infinity. This was also 1 to infinity. All right, this is just like what we did, but it's going to be a lot easier, right? So what you're supposed to do is you realize what you replace the x with. So figure out what x is replaced with. But here it's an x, and here it's obviously a 4x, right? So it's just x to 4x. All right. So then you do your interval. The old interval is x is going to be between -1/5 and +1/5, right? That's just from right here, the interval as it's given. But we're replacing the x with 4x. So we do that. So you replace the x with 4x, just right here. That's not what I wanted, just right here. So we do that, maybe. So we get -1/5. X is going to be replaced with 4x, like so. Oops, no. And then you solve for x. How do you solve for x? Looks like we're just going to divide everything by 4. And that's it. So if you divide everything in that by 4, you're going to get -1/20 is less than x, which is less than 1/5/4, which is also 120. So you have that. And then your interval is, so the new interval is -1/20 to +1/20. And that's that. Okay, and just went through the whole homework, and that's it. So this is a nice, relatively short lecture. So good luck with that. See you next time.